Hey there, fellow math enthusiasts, adventurers, and all around awesome people. Welcome to my corner of the internet. I'm Mr. Le Cordeur, and today we'll be looking at the memorandum discussion of term 1. So what I want you to do is go to the back of your book, all right? In your maths book, go to the last page. On the last page that you can find, if you have some stuff there, just draw a line underneath of that. And then what you can do for me, you can start there and you can write what we're going to do. So today we're going to do a memo discussion, and that's exactly what you're going to write down as your heading. So you go there and you write down memorandum discussion. All right? Memorandum discussion of control test term 1, 2024. And then to the right hand side you write today's date. Today is not the 1st, not the 2nd, but it is the 3rd of April, and you write the date out in full. You can take your ruler there. You see I also am supposed to have a ruler here. Let's see if I can find my ruler. You can't see it now. I'll show you next time where my ruler is. All right. So you take your ruler and you underline that. Nice and neat there. You underline the heading. And then you draw a nice and neat line there for yourself like that. All right. For you it's a little bit easier than I'm currently doing it. I'll increase the size for you to see clearer now. I hope everyone can see clearly now. Is that fine with you guys? Right. So I'm going to hand out the test later. I have a copy of the test and I will also try to share it with you on the video. So the first question there, they give us a set of different numbers. The first number is -7. No? Then we have square root of 35. Then we have 5, 8. And then we have 71 over 3. Then we have square root of 9. Who can tell me what is the square root of 9? 3. No, the square root of 9 is 3. Then we have 2. Then we have the square root of -6. Then we have 0. Then we have 36. And then we have 18 over 0. And then our last value is a number that it's actually something that looks like this. Who knows that symbol? Pi. All right. So you're quite familiar with pi. That's great stuff. You guys are definitely the best grade 9B class. No. So let's go, and now we're going to do the first question now that they ask us there is, they ask us at question number 1. You don't have to write down the question, you can just listen to the question. The question number 1 there, maybe, I'm going to pause the video, I'm just going to hand out, maybe you can just ask someone to hand out this test, and then we're going to do, because it's best for you to see it while we're working through it. Welcome back, viewers. Like I said, we are here with the grade 9 class, 9B of Noordepal High School in the year 2024. So, I'm Mr. Le Cordeur, your go-to guy for all things maths, and I'm stoked to have you here. So, let's look at this question now. We have question 1 as given to you. Consider the numbers above and answer the questions that follows. Now, if you have the answer to the question, you can just raise your hand. The question 1.1, they ask us for write down 2 rational numbers that does not fall under the whole number set. Yes, I have a hand there. Can you just give us your name before you answer? All right, and what is your answer? All right, 0, let's just check. Isn't 0 a whole number? It's a natural number. All right, so they say that doesn't fall under the whole number set. But the other answer was? 71 over 3. That sounds like a good answer. So we write down 71 over 3. Anyone else got there? Because there's 2 marks allocated there. Anyone else has another one? Kwana, okay. What is your answer? -7,7. That's great stuff. Yeah, you see, I can actually walk out of the classroom now because you have all of the answers. So you don't need me here. Very, very intelligent class that we are dealing with here. So, yes, viewers. Now 1.2, they ask us 1.1.2. They ask us write down, list the prime numbers. This is not all of the prime numbers. This is the prime numbers that are here on display. I see a hand. All right. The square root of 9. Because that answer is 3. That's right. So we write down the value that we have there is the square root of 9. Then the square root of 9, we say that value is 3. So that's one possible answer. Square root of 9. Anyone else has another answer? There's the back. There's a hand. 5. Great stuff. 5 is a prime number. Alright, and then 2. 2 is actually the only even prime number. Alright, so great stuff. Can we move on now? That's 1.1.2. Going on to 1.1.3. They ask us there, let's just read the question. Write irrational numbers. Alright. Square root of 35. That sounds like an appropriate thing to write down. So we're going to write down there. That is a rational number. Because if we go to the calculator, let's quickly go to the calculator. Let's call him. The calculator that I use, his name is Uncle Casio. Alright, so let's call Uncle Casio. Call Uncle Casio. Uncle Casio. Call him again. He didn't hear me and he's still sleeping. It's the old guy. Call him again. Alright, there's Uncle Casio, no? So, Uncle Casio, can you tell us what is the square root? Where is the square root again? Second row number 2. That one? Alright, the square root of 35 is... Oh. So, yeah, but in actuality, that number doesn't end. No? So, we have there what we call a surd. That number actually continues, but the calculator just rounds off there. So, that is why 35, the square root of 35. And then another hand, perhaps. There's not only one learner, there's there perhaps other learners. Mr. Moses, what do you have there? Yes. He's looking around, yes? Vuya says pi is also an example of a irrational number. Going on, we have the 1.1.4. Write a factor of 25 from the numbers. No? A factor. Alright, so the answer there is not too difficult, I think. And I hope I'm right. You need to help me because I don't know the answers to this one. Yes, and Sandwell says the answer is 5. Let's hope he's right. Alright. Going on there, we have 1.1.6. Given that 18 over 0. Oh, did I skip? Sorry. I'm too fast, eh? Thank you for reminding me. Sometimes that happens. My mouth is too slow for my brain. So, in actuality, I'm doing tomorrow's work already in my brain. But my mouth is still talking today's work. So if I move too fast, just to remind me, I need to come back. Alright, so we had number 1.1.5. They ask us, give a square number. Now, what is a square number? Yes. Your hand is up. Yes. A square number. Alright. He says he doesn't know. Let's just recap. What is square numbers, for example? A square number, I'm going to give you an example of a square number. The first square number is, let me just write in a different color so you can distinguish. Because this is my explanation now. A square number is, for example, 1. The next square number is, I think, 4. And then the next square number is supposed to be 9. And then the next number is going to be 4, 9. Alright, so that's going to be 16, and then 25 is another example of a square number. 36 is another example. Let's continue. Let's do the first 10. So that's going to be 36, and then it's going to be 49. And then after 49, I think it's probably going to be 64, and then 81, and then 100. And that's the first 10 square numbers. Now why do we say it's a square number? Because if we have a shape, That doesn't look like a nice square, but no. If I have a shape and I say this side is 1 and that side is 1 and I multiply it with each other, then I get 1 times 1. Now what is 1 times 1? Is 1. And if I say 2 times 2? 2. Alright, 2 times 2 is not 2a, it's 4. Alright, so we're actually saying it is the number multiplied with himself. So if I say the 1 squared, 2 squared, here is 3 squared, 4 squared, and so we continue. Alright, 100 is 10 squared. So that's the first. Now if you look at the examples there, the answer there is 36. We're quickly going to an ad break. See you after the ad break, and then we will continue with this. Welcome back, all the math enthusiasts and all around awesome people. So if you just missed the previous session, we've looked out at the memo discussion, and we are here with the grade 9 class of Noordepal High School. They say the best school in the Western Cape, but that is still measured in time. We are currently looking at question number 1. It has to do with classification of numbers, and we are at question number 1.1.6. Given 18 over 0 and square root of negative 6. One of these numbers are undefined and one is unreal. State which one is unreal. Just another name for unreal, we also know it as imaginary numbers. Alright, so imaginary numbers in this case will be the square root of negative 6. So then you can write down that answer for yourself. It's 1.1.6, the square root of negative 6. Now they ask us in the next question there, question number 1.7, now classify 18 over 0. 18 over 0, we can classify that. They actually gave us the answer away in the previous question. 1.1.7, we write there, it is undefined. Because anything divided by 0 is not possible. It is impossible, and therefore we say this is undefined. Moving on to question number 2 there. The question states, write 6,480 as a product of its prime factor as its prime factor. So we're first going to write question 2. We're going to use our ruler to underline that. So we're going to write question number 2. Just let me go down a little bit so everyone can see. We're going to use our ruler, underline it, and then we're going to answer the questions. Now, as I stated already, they asked for the prime factors of 6,480. So let's go do that. I'm going to do it by the ladder method. So it's going to 6,480. Don't know which way you have been taught this, but I prefer this method because it saves me a lot. So 6,480. What I do, I take the smallest prime number because they ask me for prime factorized. So I'm going to take, what is the smallest prime number? 2. So I can say 2 goes into 6. How many times? 3 times. 2 goes into 4 2 times. And 6 goes into 8 4 times. And then we have there 2 goes into 0 0 times. So I can take 2 again, and then I'm going to say 2 goes into 3, how many times? Once. But when I go, there's going to be a remainder of 1. So that the remainder of 1 is quite important. I write it down there. So now I ask myself, 2 does not go into 2, but it goes now into 12. So how many times does 2 go into 12? 6 times. Alright, and how many times does 2 go into 40? 20 times. All right, so 20 times, it goes into 40. She's correct. It goes into 4 twice, but it goes into 40 2 times. Can I take 2 again? Yes, we can take 2 again. So we take 2 again and we say, all right, we're going to take 2 again. 2 goes into 16. How many times? 8 times. It goes into 20. 10 times. Can 2 go into that number again? Yes. 2 can go into there again. And that's going to bring me, it goes into 8. How many times? 4. It goes into 10. 5. All right, because it can't go into 1. That's why I put down a 0. And now my next number is going to be, so now I see that isn't the even number anymore. So that means it's not divisible by 2. So I now go to my next prime number, and my next prime number is 3. So I go to 3, and I ask myself, can this number go into 405? I think so. If we divide there 405, let's see, 3 goes into 4, how many times? Once, all right? We write down the 1. But if I say 1 times 3, there's going to be a remainder of 1. I take that 1 over. So 3 goes into 10. How many times? 3 times. So we write down the 3, and then there's going to be another remainder. 3 times 3 is equals to 9, minus the 10. So I have a 1 that's remaining there. All right, so 3 goes into 15. How many times? 5 times. So I have there 135. All right, now I ask myself, can 3 go into that number as well? Yes. All right, 3 can't go into 1, but 3 can go into 13. How many times? 4 times. All right, so I write down the 4, and then I say myself 4 times 3 is equals to 12, and then 12 times what? Did we make a mistake here? What is 135 divided by 3? 45. Yeah. Oh yeah, that's 15. All right. Then we do a 3 again. 3 goes into 45, 15 times. Well done. That's quick and fast. Can 3 go into that again? Yes. How many times does 3 go into that? 5 times. All right, so then we have the... Why are you doing this to me now? So 3 can go into this as well. How many times? 5 times, and then 5 goes into that. And then we should always end up here with a 1. No? Yes, we should always end up there with a 1. If you don't end up here at the bottom with a 1, then you're not done yet. Right? Or you made a mistake perhaps. So what we do now is these numbers right here are the factors. And technically your answer is supposed to look like this. We're going to say 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3 times 5. But isn't there a shorter way how can I write this? Yes, we can use the exponential form. So we can say that's 2 to the power of 4 times 3 to the power of 4 times 5. And that's 5 to the power of 1. Good. Now, if you do this and you go to your calculator, these type of questions, they were supposed to be in this question, there was supposed to be an instruction where they ask you to do this without the use of a calculator. All right, so you can, and don't tell anyone that I told you this, but you can check your answer with a calculator. So all you do is you say 2 to the power of 4, right? And then you step down, then you say times 3 to the power of 4, and then we say times 5 is equals to 6,480. Now, I'm going to tell you or share a secret for those of you who didn't know. If you have a Casio calculator like this, what you also can do, but you're not going to get all of the marks. What you can do as well, you can go to your Casio calculator, you can type in the number. What is the number? 6480. You type in enter there, you type in shift there, and then you type in equal sign, then shift, and then you type factorize there. Everyone didn't know that, so if you didn't know that, if you did know how to do that, please write your name down in the comment section below. All right, so now we're moving on there. The next question they ask us is the question that is next. Determine the HCF. What does the HCF stand for? Highest common factor. Well done. And LCM? So loudly wrong. And that is let me just pause here. I'm not going to share that with all. The question states there at question number 2.1.2, determine the HCF and LCM of 156 and 405 if the numbers are already given to us in prime factorized form. Now what we're supposed to do, a nice thing for you to do is to determine them. There's a short way of determining this. I would go copy that. I wouldn't do the prime factorization again because it is already done for me. Alright, so I would say 156 is equals to, in prime factorization, it's 2 to the power of 2 times 3 times 13. Now for the LCM of what? The LCM of 156 and 405. There's a shortcut to determine the LCM. You use all of the factors without the repetition and use the highest exponent. That is a secret. No? Listen carefully to the instruction. And if you're smart, if you're really smart, you can write this down. To determine the LCM, you use all of the factors without the repetition and you use the highest exponent. And then you have the LCM. Check now. I'm going to do, no? That is the secret. And I'm going to apply the secret because knowledge is power. So that means it's 2 times 3 times 5 times 13. But now I use 2 to the power of 2, 3 to the power of 4, and 5 to the power of 1, and 13 to the power of 1. Then I can just type this into my calculator, and I get my lowest common multiple of this. And that will be 21,060. You can go check on your calculator if that is the correct answer. Alright. For the HCF, I'm going to say another secret. For the HCF of what? And I want you to write it down the same as I am writing it down. I'm going a little bit down. The HCF of 156 and 405. We're going to write. Now to determine the HCF, I only check for the factors that are the same. Alright? And if I find any factors that are the same, once again, good opportunity to write that. For the HEF, I want to determine the HEF, and I have them written in prime factors. I only check for the factors that are the same, and then I use the lowest exponent. I'm going to repeat that secret. Please do not share the secret with anyone else. Grade 9. HEF, you check for the factors that are the same. And if you have the factors that are the same, use that factors with the lowest exponent. So let's check at this. 156 and 405. For the factors that are the same. What is the factors here? The factors at 405 is 3 and 5. What is the factors at 156? 2, 3 and 30. What is the same between those two? 3. Because 3, let me just do this. Because 3 is there, but it is here as well. But in the one example, or in the first one, it is 3 to the power of 4. And in the second one, it is 3 to the power of 1. And what did we say? We're only going to write down the factors that are the same. And then we're going to use the one that has the lowest exponent. Between 4 and 1, what is the lowest exponent? 1. So that's why our answer is 3. So the LCM is 21,060 and our HEF is 3. Moving on now to the next question. They ask us at the next question, determine the following without the use of a calculator. And this is nice questions we have here. So let's go without the use of a calculator. Determine the following. The first one, they have their 2.2.1 is going to be 216 divided by negative 6. Right, now there's many ways of how you can do that. You can ask yourself 216. What is a positive divided by a negative? Negative. So you know your answer is going to be negative. Now you can ask yourself 216 divided by 6. Your answer is going to be 36. But it's going to be negative 36. Now if you have 36 fingers, you can count that on your fingers somehow. Right? And you can see that you're going to get to 216 again. So your answer there is negative 36. Looking carefully at this question, they ask you specifically without the use of a calculator. So you need to show your calculations. And the next question they ask us, 1 plus 3 multiplied with negative 2 squared. We are supposed to use the rules of BODMAS here. So that means we first need to do the brackets. So if we do the brackets first, I get the 1 is going to remain there for now, plus the 3 is also going to remain there. I need to do the brackets. So that bracket is, what is anything to the power of 2 mean? It means the bracket multiplied with itself. So it's a negative times with a negative, which equals to a positive. So that is positive 4. Then I have, what is 3 times 4? 3 times 4 is 12. And then I have, which is equals to 1 plus 12. And that answer is 13. That answer right there is 13. Moving on to the next number now, question number 2.2.3. 2.2.3, we have the 24 minus 8 divided by 2 to the power of 3. Now 2 to the power of 3 is actually, so that's 24 minus 8 over 2 to the power of 3. What does 2 to the power of 3 mean? 2 times 2 times 2, 3 times. So that's 8. And then we're going to say, what is negative 8 divided, 8 divided by 8? It's 1. So there we have 24 minus 1. What is 24 minus 1? Great stuff, grade 1. Are you not grade 1? Alright, because some of you are sleeping like grade 1s. So please wake up and pay attention like grade 9s and work with us. If you are like a grade 9, or if you, I would like you to behave as such. The next question there that we have is negative 6 squared over negative 3 multiplied with bracket negative 2 minus negative 3. I hear a lot of conversation here. So we're going to say, what is negative 36 squared? So that answer is going to be negative 36 over negative 3 multiplied with, let's do the bracket, so we first remove, and then we have a negative times with a negative, so we have negative 2, negative times with a negative is equals to a positive, so we have the negative 2 plus 3, then a negative divided by negative is also equals to a positive, so there we have 36 divided by 3 is equals to 12, and then negative 2 plus 3, negative 2 plus 3 is equals to 1. What is 12 times 1? 12 times 1? 12. You see, that's why I said, are we grade 1 or grade 9? Because we are thinking like grade 1s here. It's all in the attitude. Continuing now with 2.2.5. we have a square root, but underneath the square root we have a fraction. This is a nice one. So we have this square root of 9 over 4. Oh, am I a step ahead? You see, I told you I was by, what is the square root? The square root is? It's 2 and 1 over 4. Alright, so that is a mixed fraction. What is actually standing there is 2 and 1/4. So first thing that we need to do is we need to convert from a mixed fraction to a improper fraction or a common fraction. What we're going to do, how we do that is we're going to say 4 times with 2 plus the 1 on top. You see there why I was already by tomorrow's work. So that was 9 over 4. Then we have 9 over 4. Now we can all under the square root, so we can have now this. So we can write the square root of 9 over the square root of 4. Who can tell me what is the square root of 9? 3. Well done. And the square root of 4? 2. There's your answer, 3 over 2. This is too easy. Then we're moving on to question number 2.2.6. There we have the cube root of, what do we have there? Another negative there. Alright, so it's going to be 1 million. Like that. So the first thing is we start from the first negative cube root. What I would do, I would make the number alright, so guys and girls, We're going to leave the cube root quickly, and then we're going to do this now. We're going to say that is a negative answer, and then I'm going to write 1,000,000 as in exponential form. No? So let's write 1,000,000 in exponential form. That's going to be 10 to the power of 6. Because they ask you, remember they ask you in this step, and that's why you should write it down, please. This is one of the easier ways to do this. They ask us to do this without the use of a calculator. All right? So we convert it to exponential form. Then what we can do, because we have, and there's a rule, don't know if you know the rule, but the rule says if I have, for example, a square root, and I have a to the power of 2, and I want to get rid of the square root, I just need to remember that there is a invisible 2 outside. Alright, so what I can say then is going to be the base, and then the exponent inside, divide by 2. That is for a square root. So what we do then here is we're going to say that's going to be cube root of 10 to the power of 6. But I'm going to divide the 6 by 2. So what is the answer going to be? 10 to the power of 3. So that's actually negative 10 to the power of 3, like that. And 10 to the power of 3 is what? 1,000. And what is the cube root of negative 1,000? It's negative 10. There's your answer to that one. We have one more to go at this question. Question number 2. Alright, question number 2 is 2.2.7 is where we have negative cube root of negative 1, and then 4 is negative 2. Let me just see the question. Alright, so we have the negative 1, negative 2, but that is squared, and then we have negative 2 again. Alright, I'm going to simplify this. So this now becomes negative cube root. I'm first going to simplify the square there. So that's going to be negative, and then negative 1, and then negative times a negative is equals to a positive. So that's positive 4, and then times with a negative 2 there. So that becomes now a negative times with a negative, which is equals to a positive. So that answer is going to be negative cube root of negative 8. And the cube root of negative 8 is equals to a negative times with a negative 2. So that's a double negative, so your answer is a positive 2. Okay. We're going to pause there. I'm going to give you an opportunity to copy this. Make sure you have all of these answers in your book. And then